Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is all about working out the masses of lead nitrate that's formed. It's one of the physical chemistry amount of substance topic. This is a year 1 topic, which of course year 2s will also need. It's a request for one of the students. It's a short one, 4 marker. Let's see what we can do. Okay, so lead nitrate may be produced by the reaction between nitric acid and lead to oxide, as shown by the equation. So lead oxide, nitric acid, lead nitrate, and water. An excess of lead oxide was allowed to react with 175 centimeters cubed of 1.5 molar. So 1.5 molar nitric acid. So there's your nitric acid. Calculate the maximum mass of lead nitrate produced, which could be obtained from this reaction. So in other words, you got an excess of lead oxide. Okay, so in other words, this will be the limiting reagent. So okay, let's do this. So the first thing that you need to do is, obviously, even if you don't know what you're doing, just work out what you can from the data given. All right, so I've been given volume and concentration. So the first thing what you have to do is find the moles of nitric acid that you've got. Okay, and based on the equation, then you work out how many moles of lead nitrate you can get, and then change that lead nitrate moles to mass, because they're looking for mass of lead nitrate that's needed. All right, okay, so let's do that. Right, so the equation, so this is now moles of nitric acid, okay, which equals, so obviously it's CV over 1,000 equation. So concentration you've been given is 1.5 times by, you've been given the volume, which is 175 centimeters cubed, and then divide that by 1,000 to give you the moles, and that moles will be 0.2625. So that is the moles of nitric acid. So you worked out the moles of nitric acid, which is 0.2625. Now, looking at the equation, the ratio of nitric acid to lead nitrate is 2 to 1. Okay, so ratio of nitric acid to lead nitrate is 2 to 1. And so therefore what you'll need to do is you need to say, okay, well, if I've got that many moles of nitric acid, how many moles of lead nitrate? So you need to divide that by 2. So what you do is, so this is moles of lead nitrate that you can get is equal to, so again this time, so all you do is you say 0.2625 divided by 2, and that gives you 0.13125. Now, if you remember, I said to you about not copying everything from the calculator. Okay, not copying everything from the calculator, right? If I'm looking at the question, I can see that they've given you 3 sig fig. Okay, information, so in 3 significant figures. So this is 3 significant figures, this is 3 significant figures. So the answer I'm probably going to give is 3 sig fig max. Okay, so I'm not going to start putting down everything on the calculator. I'll be using 3 significant figures throughout in between the calculations, or more, okay, but certainly nothing less than 3. But I'm not going to start giving 10 sig fig in between the questions. Okay, so what I'm going to do is I'm going to change that. I'm going to say, okay, well, 1, 3, 1, 2. 4 sig fig, okay, but nothing more, right? Certainly nothing less than 3 sig fig. All right, so that's what I'm going to be using. Okay, so now we know that the lead nitrate that we will get moles is 0.1312. Okay, however, they've not said moles, they've said mass, and sometimes students just leave that because they're in a rush and they just move on. But remember, that's moles and they want it in mass. So now all I do is I need to change that into mass. How do I do that? Well, using the equation, number of moles equals mass over mR, and therefore I need to work out mR. mR of what? mR of lead nitrate. Okay, and if you work out mR, and you can work it out on the periodic table, you can have a look, you'll notice that the MR is 130, oh sorry, wrong, it's 331.2. yeah, not a problem if you're going to use all 4 sig fig, remember, yeah, nothing less than 3 sig fig, but you know, use the periodic table. So 331.2. All right, that's the MR, and of course the mass is what I'm trying to work out. So all I need to do is, I've got the moles there, I've got the MR, rearrange this equation to give you mass. So it will be mass equals Mr. moles. Mr. or MR is 331.2, and then moles is 0.1312, which equals 43.45. Okay, so it actually equals 43.45344, right? And let me just write all of that down just to highlight that point again. 43.45344, but I'm not going to leave the answer. In fact, I don't need to write that down. I just wrote it just to show you, right? Do not write all of that down. Maximum 3 sig fig, because the question, the data in the question is 3 sig fig. So I'll give that 43.5, and that's grams. Okay, and so that is the grams of lead nitrate that you'll end up with. Okay, marks are, so marks, there's your mark, one here, it's only 4 markers, so 1 mark there, 1 mark here, yeah, 1 mark here to work out the MR, and then of course 1 mark for the final part. Where students go wrong in this question is, or often went wrong when this question was in the exam, was they had difficulty working out the MR. Don't understand, but anyway, you know, use the periodic table and use the MR. I mean, sometimes they ended up using atomic numbers. Come on, people, yeah. You know, when you're trying to work out the mass of a compound, you use the MR, not the AR, yeah, not the atomic number, but the mass number from the periodic table. Okay, so that's one of the common mistakes that they made. The other common mistake is they forgot to look at the ratio. So once they worked out the nitric acid moles, so they use that many moles of nitric acid instead of lead nitrate. They use that many moles of nitric acid in this equation. So they said, okay, moles, yeah, is for the nitric acid, and then they worked out the, you know, the MR of 331, and then they worked out mass. Well, that's the moles. That should be the moles of the lead nitrate, not the nitric acid. So lead nitrate. Okay, so that's another common mistake, that they didn't ratio it down. They just used whatever they worked out there straight into that equation. Okay, I think that's it. The other thing is that if you get this wrong, or if you get this question, you know, this part wrong or this part wrong, you don't get that last mark. The only mark you'll get is working out the MR. Okay, because they want to know, do you know how you're doing this question? That's what they want to know. Yeah, it's called process marks. Yeah, so they're looking at the process that you're following. So you've got to show the process. So please show the process. Don't do everything, you know, on the calculator. Okay, just in case you make a mistake. Anyway. All right. Okay, and it was as I said, it was a quick one, just 4 marker. It was a request. I thought, okay, I'll show it to you. Right. Try it. Give it a go. Give, you know, questions like that a go. So there's a second part to that question. See if you can do that later. It's all to do with ideal gas equation. Yeah, I'm not going to do it, okay, unless people want me to do it. So give it a go. Leave any comments, any questions, any suggestions down in the comment section below, and I'll see you next Tuesday. Bye.